The universe is a graveyard of cosmic mysteries, but none are as shocking as this. A galaxy that lived fast, died young, and defies everything we thought we knew. Imagine a stellar city, home to billions of stars, burning bright in the infancy of the cosmos, only to collapse into silence before the universe even had a chance to blink. This isn't science fiction. This is real. And it's rewriting the rules of astrophysics right before our eyes. Astronomers have just uncovered a galaxy so ancient, so massive and so dead that it shouldn't exist. It formed in the first chaotic fires of the Big Bang, grew to an impossible size, and then, without warning, shut down. No more stars, no more light. Just a cosmic corpse, floating in the darkness, waiting 13 billion years to be found. The discovery is so baffling that it threatens to upend our entire understanding of how galaxies live and die. This galaxy, known only by its cryptic designation, formed over 10 billion stars in less than 700 million years, a blink of an eye in cosmic time. Then, just as suddenly, it stopped. No gas, no new stars, just a silent, red graveyard drifting through the void. How? Why? The answers could change everything. Galaxies aren't supposed to die this fast. In the early universe, they thrived, feeding on gas, birthing stars in furious bursts, growing bigger and brighter over billions of years. But this one didn't follow the rules. It grew too fast. It died too soon. And now, scientists are scrambling to explain how such a monstrous galaxy could exist at all. The James Webb Space Telescope, JWST, has shattered our expectations before, but this is different. This galaxy, hidden in the deepest reaches of time, shouldn't be here. Current models say massive galaxies take billions of years to form. Yet this one did it in hundreds of millions. And then it just ended. No warning, no slow fade, just an abrupt, violent shutdown. What killed it? A supermassive black hole? A cosmic catastrophe? Or something even darker? Most dead galaxies we see are old, ancient relics from a quieter, colder universe. But this one died in the cosmic dawn, when the universe was still a seething cauldron of creation. Finding it was like stumbling upon a fossilized dinosaur in the middle of the Cambrian explosion. It doesn't make sense. The galaxy's light, stretched and warped by 13 billion years of cosmic expansion, tells a terrifying story. Its stars were already old when the universe was just a toddler. Its core was dense, packed with the mass of billions of suns in a space smaller than some star clusters. And then, nothing. No new stars, no rebirth, just a frozen relic, drifting in the abyss. This isn't just a dead galaxy, it's a murder mystery. The evidence is clear. Something killed this galaxy. But what? Some say a supermassive black hole, feasting on gas and spewing radiation, could have choked off star formation. Others suggest a cataclysmic collision, a cosmic train wreck so violent it stripped the galaxy of its lifeblood. But none of these theories fully explain how a galaxy this massive could form and die so quickly. The real horror? There might be more of them. If this galaxy isn't a freak accident, if it's just the first of many, then our entire understanding of galaxy evolution is wrong. The early universe wasn't just a nursery for infant galaxies, it was also a graveyard. This discovery isn't just a challenge, it's a revolution. Every model, every simulation, every theory about how galaxies grow now faces an impossible question. How did this happen? The hunt is on. Astronomers are scouring JWST's data, searching for more of these cosmic ghosts. Each one they find could rewrite the story of the universe. Each one could force us to rethink everything. One thing is certain, the universe is stranger, darker, and more violent than we ever imagined. And this dead galaxy? It's just the beginning. The cosmos has secrets, and it's not done revealing them yet. The universe is supposed to follow rules, laws of physics, predictable patterns, a grand cosmic dance that plays out over billions of years. But then, there are moments when the cosmos throws us a curveball so extreme, so impossible, that it forces us to question everything. This is one of those moments. A galaxy born in the violent dawn of time grew to staggering proportions, and then, in the cosmic equivalent of a sudden, tragic death, it vanished. Not in a blaze of glory, not in a slow fade, but in a brutal, unexplained shutdown. And now, with the James Webb Space Telescope peeling back the layers of time, we're staring directly into the face of a mystery that defies logic. What makes this discovery so terrifying isn't just that the galaxy died, it's how it died. Galaxies in the early universe were supposed to be chaotic, messy, bursting with star formation. They were cosmic infants, still learning how to grow. But this one? It lived fast, burned bright, and then, snap, it was over. No lingering death, no slow decay, just an abrupt, irreversible silence. The numbers alone are staggering. This galaxy, lurking just 700 million years after the Big Bang, somehow crammed 10 billion stars into a space only 650 light-years across. To put that into perspective, our own Milky Way spans 100,000 light-years. And yet, this ancient beast packed nearly a quarter of its stellar mass into a volume 150 times smaller. The gravitational forces at play would have been apocalyptic, a crushing density where stars lived and died in a frenzied rush. And then, nothing. Scientists are calling it the Great Cosmic Anomaly, a relic so out of place that it shouldn't exist. Current models of galaxy formation can't explain it. Simulations crash when they try to recreate it. Even the most extreme theories, black hole feedback, catastrophic mergers, dark matter oddities, fall short. This galaxy didn't just break the rules, it annihilated them. And here's the real kicker. It might not be alone. Deep field observations from JWST are now revealing whispers of other dead galaxies in the early universe. Ghosts floating in the darkness, relics of a time when the cosmos was supposed to be young and wild. If these findings hold, it means we've been wrong about the universe's early years. It wasn't just a period of creation. It was also a time of destruction, of galaxies rising and falling in cycles we never imagined. What could possibly cause such a thing? One leading theory points to supermassive black holes, monsters lurking in galactic cores, feasting on gas and belching out enough radiation to sterilize entire galaxies. But even that doesn't fully explain the speed of this shutdown. Another idea suggests that dark matter, the invisible scaffolding of the cosmos, might have played a role, collapsing in strange ways to strangle star formation before it could stabilize. Or perhaps there's something even more exotic at play. A force, a phenomenon, a rule we haven't discovered yet. The implications are earth-shattering. If galaxies could die this quickly in the early universe, it means our understanding of cosmic evolution is incomplete. It means the universe had phases of violence we never accounted for. And worst of all, it means there could be entire populations of dead galaxies out there, hiding in the shadows, waiting to be found. This discovery isn't just about a single dead galaxy. It's about the unseen forces that shape the cosmos. It's about rewriting the story of how everything came to be. And most of all, it's a humbling reminder that the universe always has more secrets. The question now isn't just how this happened, it's what else we don't know. And with JWST staring deeper into the abyss than ever before, one thing is certain. The universe isn't done shocking us. The galaxy died. Science can't explain why. And that is only the beginning. The cosmic detective story deepens as astronomers uncover even more disturbing clues about this primordial galactic murder mystery. Just when we thought the universe couldn't get any stranger, new data reveals this ancient dead galaxy may have been killed by something far more sinister than we imagined. A cosmic vampire of unimaginable power. The smoking gun, a monstrous black hole that didn't just stop star formation, but actively devoured the galaxy from within, leaving behind a hollowed-out stellar carcass. Recent spectroscopic analysis shows telltale signs of extreme quenching, the astrophysical equivalent of a galaxy having its throat slit. The chemical fingerprints in the remaining starlight reveal abrupt, violent changes in composition that suggest not just a natural death, but an assassination. This wasn't a galaxy gently running out of gas. It was a cosmic hit job, executed with terrifying efficiency when the universe was barely 5% of its current age. The killer left virtually no evidence behind, save for this frozen snapshot of stellar genocide. Even more chilling is what this means for our search for life in the universe. If galaxies could die this quickly and violently in the cosmic dawn, entire civilizations may have been snuffed out before they ever had a chance to evolve. The universe's first potential life-bearing worlds could have been rendered sterile almost immediately, their parent galaxies murdered in their infancy. This changes everything we thought we knew about the timeline of cosmic habitability. The plot thickens with the discovery of strange glowing halos around similar dead galaxies found in subsequent JWST observations. These eerie afterglows suggest something truly bizarre, that the death of these galaxies may have triggered secondary phenomena we've never witnessed before. Some theorists speculate these could be the signatures of dark matter reacting to the galactic demise, or perhaps even evidence of exotic physics at work in the early universe's extreme conditions. Perhaps most unsettling of all is the realization that we may be seeing just one frame of a much larger cosmic horror story. If galaxies could rise and fall this quickly in the early universe, entire cycles of cosmic life and death may have played out before our own Milky Way even began to form. The universe's history might be filled with lost chapters of dead civilizations, extinct alien empires, and cosmic dark ages we never knew existed, all erased by time and the expansion of space itself. As JWST peers ever deeper into the infrared shadows of the early universe, each new observation brings more questions than answers. The discovery of this dead galaxy hasn't just challenged our models, it's revealed an entire hidden dimension of cosmic violence we never anticipated. The universe, it seems, had a dark and turbulent youth that makes even the most violent events we see today look tame by comparison. This isn't just about rewriting textbooks, it's about confronting the possibility that the universe operates on scales of time and destruction that dwarf human comprehension. That in the grand cosmic drama, entire galactic civilizations may rise and fall in the blink of a universal eye, and that what we see as the calm, orderly universe today may just be the quiet aftermath of an ancient, forgotten storm. The more we learn, the clearer it becomes. We're not just studying a dead galaxy, we're staring into the abyss of cosmic history, and the abyss is staring back with secrets we're only beginning to comprehend. The universe, it seems, has been keeping far darker secrets than we ever imagined. And this dead galaxy? It's just the first whisper of a truth we're not sure we're ready to hear. The implications of this discovery send shockwaves through everything we thought we knew about cosmic evolution. Cutting-edge simulations now suggest this wasn't just an isolated incident. It may represent an entirely new class of flash galaxies that burned with terrifying intensity before vanishing without a trace. These cosmic mayflies lived out their entire life cycles in what amounts to a geological instant, compressing processes that normally take billions of years into mere hundreds of millions. New analysis of the galaxy's spectral signatures reveals something even more perplexing. Its stars show chemical abundances that shouldn't exist at that early epoch. There's evidence of rapid, extreme metal enrichment that defies conventional models of stellar evolution. It's as if this galaxy discovered some forbidden shortcut to cosmic maturity, aging at hyperspeed before meeting its abrupt demise. The stellar corpses left behind tell a story of frantic, almost desperate star formation, unlike anything we've seen before or since. The timing couldn't be more significant. This galaxy died during the epoch of Rhionization, when the first starlight was struggling to pierce the cosmic fog of neutral hydrogen. Its death may have altered the very fabric of the early universe around it, creating a bubble of ionized gas that could have influenced the formation of neighboring galaxies. We might be seeing the first evidence that dead galaxies could shape their environments as dramatically as living ones, a revelation that turns galactic archaeology on its head. Recent discoveries of similar objects at slightly later cosmic times suggest we may be looking at the tip of an iceberg, an entire lost population of early galaxies that lived hard and died young. Some theorists propose these could represent a previously unknown channel of galaxy formation, one where dark matter halos assembled with freakish efficiency in the ultra-dense early universe. Others speculate about even more exotic possibilities: primordial black holes, phase transitions in the quantum vacuum, or interactions with mysterious dark sector particles. The most haunting question remains: was this galaxy's death an accident of cosmic circumstance, or is there something fundamentally flawed in our understanding of how the universe works? As we push JWST to its limits, searching for more of these cosmic ghosts, each new observation seems to deepen the mystery rather than solve it. The universe appears to be telling us that its early years were far more complex and violent than our models predicted, and that we've only just begun to scratch the surface of its secrets. This dead galaxy stands as a monument to our ignorance, a cosmic Rosetta Stone waiting to be deciphered. Its discovery has opened a new frontier in astronomy, the study of what we might call failed galaxies, systems that somehow missed their chance at cosmic longevity. As we continue to probe deeper into the universe's past, we may find that such objects were not the exception, but the rule. That the early cosmos was a graveyard of stillborn galaxies whose stories we're only now learning to read. The implications extend beyond astronomy into fundamental physics. If galaxies could form and die this quickly in the early universe, it suggests physical processes operating at efficiencies we've never observed before. Some researchers whisper about the possibility of exotic stellar physics, nuclear fusion pathways, or stellar life cycles that no longer exist in today's more sedate universe. Others wonder if we're seeing the fingerprints of physics beyond the standard model, written in the ashes of dead stars from the dawn of time. One thing is certain: this discovery has torn a hole in our understanding of cosmic history. As we stand at the edge of this new frontier, staring into the darkness of the early universe, we can't help but wonder what other surprises are waiting to be uncovered. The universe, it seems, was far wilder in its youth than we ever dared imagine, and we're only just beginning to piece together its forgotten history. This dead galaxy is our first clue, but it surely won't be our last. The deeper we probe this cosmic cold case, the more disturbing the evidence becomes. Cutting-edge, spectroscopic analysis reveals this galaxy didn't just die, it was murdered, in a way that leaves astrophysicists questioning the fundamental laws governing the early universe. The stellar corpses remaining show chemical signatures of a sudden, violent shutdown, as if someone flipped a cosmic kill switch when the universe was barely out of its infancy. New simulations incorporating this discovery paint a terrifying picture of the early cosmos, a place where entire galaxies could be snuffed out in stellar holocausts lasting mere millions of years. The data suggests this galaxy may have experienced what astronomers are calling hyper-quenching, a catastrophic collapse of star formation so rapid it makes previously observed galactic deaths look like slow declines by comparison. The process was so efficient, it left behind what amounts to a cosmic fossil, frozen in time at the moment of its demise. Even more unsettling are the implications for dark matter. The galaxy's extreme mass and tiny size suggest its dark matter halo must have been extraordinarily dense, perhaps so dense it triggered some unknown feedback mechanism that strangled star formation. Some theorists speculate we may be seeing evidence of dark matter particles interacting in ways the standard model doesn't predict, potentially opening doors to entirely new physics hiding in the early universe's extreme conditions. The timing of this galactic death is equally perplexing. It occurred during the cosmic dawn, when the first stars were still struggling to illuminate the universe. This means the very first generations of galaxies may have included both thriving stellar nurseries and already dead galactic graveyards existing side by side, a finding that completely upends our timeline of cosmic evolution. The universe appears to have been capable of creating and destroying galaxies on shockingly short timescales during this violent period. New JWST data reveals another bombshell. This galaxy's surroundings show evidence of a massive starless void, as if its death created a cosmic dead zone stretching thousands of light years. This suggests dying galaxies could have dramatically altered their local environments, potentially dooming neighboring proto-galaxies to similar fates. The discovery hints at a previously unknown form of galactic seeding, where dead galaxies influence the evolution of their cosmic neighborhoods in ways we're only beginning to understand. Perhaps most disturbing is what this means for our search for extraterrestrial life. If galaxies could die this quickly in the early universe, it suggests the cosmic window for life's emergence may have been far narrower than we imagined. Entire civilizations, if they existed, could have been rendered extinct, not by their own actions, but by the violent, unpredictable nature of the early cosmos itself. The universe may have sterilized its first, potentially habitable worlds before life ever had a chance to take hold. As astronomers scramble to explain this discovery, one thing becomes increasingly clear. Our understanding of galaxy formation is woefully incomplete. The early universe appears to have operated under different rules, rules we're only now beginning to decipher. This dead galaxy isn't just an anomaly. It's a messenger from a time when the cosmos was far wilder and more dangerous than we ever dreamed, carrying secrets about the universe's youth that challenge everything we thought we knew.